All right, so let's talk about polynomial behavior, because what we need to learn about is the possible number of turning points and what the end behaviors are. So we need to know what turning points are, we need to know what end behaviors are, and then we need to know how to figure them out. So here we go. If you graph a polynomial, polynomials are curvy like a roller coaster. When you graph a polynomial, they always end up looking curvy. The first thing that we need to know about is what is a turning point. And a turning point is a point where the direction changes from up to down or down to up. That's the definition. Let me describe it to you. Start over here on the left side of the curve, and we're just going to trace this curve. So here we go. Down, 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 down. We're going down, 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 down. Ooh, we reach a spot right here, and we start going up, 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 up. That transition spot where we go from down to up is a turning point. And then we go up, 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 up. We reach a spot where we start going down, 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 down. That is a turning point. And then down, 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 down. Reach a spot, start going up, up, up. That's a turning point. That's a turning point. Any questions about that? Seem pretty straightforward? Those are the spots on the roller coaster when you're at the bottom. That's where your stomach goes down to your feet. And then this spot, that turning point, is where your stomach comes out your mouth. Right? Yep. All right, so the next thing is end behavior. And end behavior describes the direction of the tails which are the far ends of the polynomial. And what we're interested in knowing is the end behavior up or down. Oh, goodness, yes. Well, that was no good. Sorry about that. Okay. Describes the direction of the tails, which is the far ends of the polynomial. They're either up or down. So, for example, if we look at the left end of the polynomial, the left end is up. So we'd say left hand end behavior is up. Over on the right hand, we would say the right hand end behavior is down. That's all there is to that. the last thing that we need to know about are x-intercepts. And x-intercepts are locations where the polynomial intersects or touches the x-axis. Okay, so intersect means goes through. So that spot would be an x-intercept, and that spot would be an x-intercept because the function goes through the x-axis, and that spot right there would also be an x-intercept. Boom, boom, boom. Now, even though we call it an x-intercept, this spot right there doesn't really intersect. It doesn't go through, but it touches. And so we count that as an x-intercept. Okay? Who needs more time? Okay, next. Well, let's talk about turning points. The question is, when you have a polynomial, how many turning points is it going to have? Well, it turns out it works like this. Initially, we won't know exactly how many it's going to have, but we can determine the max number of turning points. And the maximum number of turning points is equal to the degree of the polynomial minus 1 where the number of turning points must be greater than or equal to 0. So that's a definition. Let's describe what that means. We're going to make a table. Actually, I'm going to change this. We're just going to call this the number of turning points. Okay, here we go. If the degree of the polynomial is 0, what's the name of the polynomial if it's 0? Constant. That's just a horizontal straight line, right? So what's 0 is the degree of the polynomial. 0 minus 1 is negative 1. But it always has to be greater than or equal to 0. So it has to be 0. If you think about a horizontal line, how many turning points does it have? None. So that makes sense. Okay, here we'll draw a little picture. Yeah, we'll draw a little picture. y equals, that would be an equation like y equals 3. Bless you. Okay. How about if we have a polynomial of degree 1? What's the name of that one? Linear. You have studied linear equations a lot. What does a linear equation look like? It's a straight line. How many turning points does it have? It's straight. It doesn't have any turning points. What's degree of the polynomial? What's 1 minus 1? 0. So say like y equals x plus 1. Remember, a turning point is a location where you go from up to down or down to up. With a linear equation, you're always going one direction, so 0 turning points. How about degree of polynomial equals 2? Let's see, 2 minus 1 is 1. Let's see, so y equals x squared. That's a second degree. Do you remember what those graph like? That's a quadratic equation. You did those in algebra. What do they look like? They're a parabola. They look like that. How many turning points? 1, and it's right there. Okay, degree of polynomial equals 3. That's a third degree. That would be a cubic. What's the maximum number of turning points? Yeah, 2. There's an example of a cubic right there. I guess I should have used green. Now, I'm going to write an equation here. This that I sketched right here could be represented by y equals x cubed minus 3x squared plus x plus 1. But what would happen if we only graphed y equals x cubed without all these other terms? Well, you could put that in your calculator, and you would find that this graphs like that. Now, this first cubic has 2 turning points. But how many turning points does this have? Doesn't it look like 1? But if we were to graph this on your calculator and you were to trace this, you would find that you're going up, 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 up. And when you reach that point, what happens? You keep going up, 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 and up. And so technically, this one has 0. It turns out that a cubic can have 2 turning points or 0 turning points. It is weird. Okay, ready for even weirder? Okay, degree of polynomial 4. What's the maximum number of turning points? 3. Now, see how this is an odd number? This can be 3 or 1. Did you see how this was 2? 2 or 0. Okay, next, degree 5. 5 minus 1 is 4. Or 2. Or 0. Let's do one more. I'm running out of room. If you do a 6th degree, you would have 5. Or 3. Or 1. And the pattern goes like that forever. Let's see, what time do we get done? 25?
35.
Oh, 35. Oh, excellent. Good. All right, next page. So that's what happens with turning points.
Get this all to these, or you're gonna take 5 minutes?
It's Staublin time. Normally it would be 5 minutes, but I got so much feedback that said you need to go slower, so I'm going slower. And the surveys. Yeah, and the end of semester surveys. Okay. So, end behavior. There's two things that we're going to look at. We are going to look at the leading coefficient, and we are going to look at the degree of the polynomial. These two things will tell us about the end behavior. And I'm drawing some examples down here. Okay, yep, I'll move it up. Okay. There we go. All right, I'm going to highlight something. I'm going to highlight leading coefficient in yellow, and then I'm going to come down to all these equations, and I want to show you what the leading coefficient is. You'll notice that all of these equations are written in standard form. The leading coefficient is the number in front